Now, one form of math they want you to do is calculating zone flow rates in gallons per minute. So let's take a finned baseboard 20 foot long with a 20-degree delta T across it. We want it at 170 degrees. So let's find out how many gallons per minute of water that is. The formula they give you is BTUs over delta T times 500 equals gallons per minute. There's your formula, okay? So let me put a square around that. There's your formula. Now you have a 500 up there. Why is there already a 500? Don't you love math problems where they already have a number in there, and you don't even know what it is yet, okay? Your next code word is charcoal. So let's look at that. How did we get 500? There, 1 gallon of water weighs 8.33 pounds. 8.33 pounds is how much 1 gallon of water weighs. I needed to know that to calculate gallons per minute on my contractor's exam. To know what that is in 60 minutes or an hour, we have to multiply it. So 8.33 pounds, which is a gallon of water's weight, times 60 minutes equals 500. So the weight of the water and the time it takes to move it in gallons per minute is 500. So that's already done for us. Now, next, we have a 20-foot baseboard with a 20-degree delta T. The water comes in at 170 and it comes out at 150. So to give up that 20 degrees, we need to know how many gallons per minute we need that water moving. So this particular brand of baseboard gives us 510 BTUs per linear foot. So for this linear footage here, each foot is 510 BTUs. Okay, you still with me? So we got 500 BTUs per foot. How many feet do we have? That's right, 20 feet. So when we multiply that, we get 10,200 BTUs. So now we got what we need for our math formula. So let's take the BTUs, 10,200, the 20-degree delta T, and multiply that by the 500. The answer we get is 1.02 gallons per minute. And that's how they did that in your book right there, okay? They want you to know how to do gallons per minute, okay? Okay, so we're on page 492, and it says the series loop math. Let's look at this. It says you design 3 terminal units, 20,000, 30,000, and 50,000 BTU. We'll assume the water supplied is 180 and it returns at 160. So how do we get the gallons per minute for 3 units when we add them together? So it says the first unit, here's your math formula, BTU, which is actually QT. Delta T times 500 equals gallons per minute. We just did that. So we have 20,000, the first terminal, the next terminal 30,000, and the third terminal 50,000. So we have 100,000 BTUs per hour. We know the delta T we said was 180 in, 160 out. So we take the delta T times 500 and we get 10,000. We know the BTUs. So gives us 10 gallons per minute is what we need for those 3 units right there at that temperature. Now your book says next, we know that there will be 10 gallons per minute of water flowing through each pipe and circulator is operating. We can now determine the temperature of the water at the outlet of the first terminal using the variation of that formula. Okay, so let's look at this math formula here they have in your book. Remember, we can determine the temperature of the water at the outlet of the first terminal using the gallons per minute we already worked out here. So we know it's 10 gallons per minute. The formula for the temperature coming out of the first terminal is delta T is equal by Q1, which is what? BTU's first terminal, Q terminal 1, Q1, divided by, and we have right here, 500 times the gallons per minute. Well, we know the gallons per minute. It's 10. And we know the first terminal is 20,000. Terminal 2 and terminal 3. So all we did was the math. 20,000 BTUs. Now 500 times 10 equals 5,000. That gives us 4 degrees. Pretty simple math. Now let's do terminal 2 and 3. Okay, so the second terminal now, second terminal is 30,000 BTUs. You're going to use the 500 times 10 is 5,000. Do the math, it comes out to 6 degrees. Your third terminal is 50,000 BTUs. Same gallons per minute, you already figured it out, and it comes out to 10 degrees. So originally we said the difference was a 20-degree delta T between 180 and 160. So let's see if that worked out correctly. The first time we gave up 4 degrees. So we started with 180, gave up 4 degrees and got 176. Then we gave up 6 degrees. 176 is left. We take away the 6 and we get 170. The third one, 10 degrees. So we have 170, take away the 10, and now we're at 160. So we know we started at 180 and we ended up with 160, and that's our 20-degree delta T. So that's what your book's doing right there with the math, okay? And they're saying you can do that with all your different piping configurations for the next few pages, and you can do it over and over and practice it like that. So it's pretty much gets redundant. They start talking about the temperatures in each separate piece of pipe, all right? Okay, your code word right now is alligator. Okay, now we're on page 1006, talking about radiant heating. 1004. Okay, your next code word is swordfish. And it says, like hot water hydronic systems, radiant heatings rely on circulation of hot water through a series of pipings. So what is radiant heating? It goes along the floors, walls, and sometimes the ceilings of the structure. If you look at 1005 right there, that page, they show you PEX tubing that can be used, which is polyethylene tubing. Now, radiant heating piping can be installed with slab on grade, dry, thin, dry. Well, what is slab on grade? Remember, grade is house level on the floor. So slab on grade says these applications can be poured concrete over them. So they look something like this. This is a slab on grade right here, okay? Then you have thin slab, where you put a thin layer of concrete over it, over the floor, and the concrete's poured over it is 1.5 to 2 inches thick. That's thin slab, okay? And the only other thing you really have in your book is in the back is solar, which just talks about using solar energy to heat the water in your house and help heat it using the solar energy. And that's about it. Read 1020, the page on preventative maintenance. The next code word is Godfather.